So this last one is experimental probability. Experimental probability. Just like you do experiments in science class to get data, they do experiments, they take data, and we can do probability from that. So here we see that the information of the number of times an event occurs to the total number of trials or times that the experiment happened. This experimental probability is all based on data. Like it says there big off on the side. Before we didn't have any data. We just assumed that that's how many times it would happen based off of how many letters there were, based off of how many pool balls were in the box, based off of the chances of rolling different numbers on a dice. Those were all theoretical, what we would expect. Now we have this table. Oftentimes we see these posted in tables. We have information from Izzy's ice cream shop. Her order's on Thursday. Now we're going to find the probability based off of this information for these different things. So that first box up top has the 3 different flavors of ice cream that Izzy had that day. She had chocolate, vanilla, and cookies and cream. And then below those, it tells you how many people ordered each of those flavors of ice cream. That middle section has the different toppings, nuts, fudge, and strawberries. And you can see how many people ordered each of those different toppings. And then on the bottom, it tells how many people got their ice cream in a dish, on a waffle cone, or in a waffle bowl. So now we have to use this data to help us figure out the probability of somebody ordering whatever kind of ice cream it is. We're going to go about it the exact same way. It's just finding the total is going to be a little bit different. Finding the total is going to be a little bit different now. So over here on the side, it says based on the table, all that information we have there on the side, what is the experimental probability, so we've got to use that data, of ordering cookies and cream ice cream in a dish with fudge. Before we only had 2 things, like 2 balls that we were trying to pull out or 2 cards that we were trying to draw. Now we have 3 different probabilities we're looking at. First, we want the probability of cookies and cream ice cream. So I'm going to abbreviate that as CC for cookies and cream. Then I want the probability of them getting it in a dish. The probability of them ordering their ice cream in a dish. Then I want the probability of them ordering their ice cream with fudge. I'm getting hungry and I already had dinner. So I want the probability of cookies and cream, the probability of them getting it in a dish, and the probability of them ordering it with fudge. And then what do I have to do with all those probabilities? Multiply them all together. So let's go through this. First, the probability of ordering cookies and cream. So right there, remember it's what we want over the total. So how many people ordered cookies and cream, that flavor that we want? We had 20 people order cookies and cream. Out of the total, our total is only going to be flavors of ice cream that people ordered. So my total is going to be adding up these numbers. How many total flavors of ice cream were ordered that day? So I need to add up just the ice cream numbers. So 14 people ordered chocolate, 16 people ordered vanilla, and 20 people ordered cookies and cream. So the total number of ice cream orders here was 50. So 20 people out of those 50 ordered cookies and cream. Now let's look at the probability of ordering a dish. So where on my table is the dish? That bottom left right there. We want to know how many people ordered a dish. 20 people got a dish out of how many total people? Again, we got to add 20 plus 15 plus 15. It's always good to double check the total number because maybe some people had gotten like 2 scoops, 1 chocolate, 1 vanilla. Maybe the ice cream numbers would be higher than those, than how it was served. So you always want to double check. So again, we see here, if we add up those numbers for all the orders, it's still 50. The total there is still 50. And then the last probability we want is the probability of someone ordering fudge. How many people ordered fudge? 30. You try finding on your own how many total people ordered toppings. How many total topping orders were there? Try that on your own for me. Three plus 30 plus 12. Only 45 people got toppings. So here it's a little bit different. I know my grandma, she just likes her ice cream plain. She doesn't put any toppings on it. She just likes it plain. So it looks like some people came through and they just didn't get any toppings, and that's okay. That's okay. So I have 20 over 50 times 20 over 50 times 30 over 45. Those are some big numbers, aren't they? A little ugly. What do you think we could do with those fractions before we multiply them, though? We can simplify them. We can simplify them. So my first 2 fractions are the same, so it's really just doing it one time. What number goes into 20 and 50? 10. I can divide those all by 10. Divide them all by 10. What's 20 divided by 10? 2. What's 50 divided by 10? 5. So now my fraction's 2/5. That's a lot easier to look at and to multiply than 20 over 50. Which there's nothing wrong with doing 20 over 50. You'll still get the same number. You'll just have to simplify some huge numbers. And it's easier to simplify when the numbers are smaller. What number goes into 30 and 45? I bet some people are going to say 5. Let's do that. Let's divide those both by 5. So 30 divided by 5 is going to give me 6. And 45 divided by 5 is going to give me 9. Does a number go into 6 and 9? Yeah, what goes into 6 and 9? 3. If you recognize before that 15 goes into 30 and 45, more power to you. If you need to take these 2 steps to simplify, that's totally fine too. What's 6 divided by 3? 2. What's 9 divided by 3? 3. So that's a lot easier now. Now I'm going to be multiplying 2/5 times 2/5 times 2/3. So if I multiply straight across, what's 2 times 2 times 2? 2 times 2 is 4. 4 times 2 gives me 8. And then on my denominator, What's 5 times 5? 25, like a quarter. What's 25 times 3? Or if I have 3 quarters, 75. So the probability of somebody ordering cookies and cream in a dish with fudge is 8/75. So 8 people in every 75 you would expect would place that order. That's a lot of work, isn't it? 3 probabilities you have to find. You have to simplify the fractions. You have to multiply them all together. There are a lot of steps. And these data ones are a little trickier. But we still need to be able to do them. So I've got one for you guys to try on your own. It's the exact same table. 14, 16, 20, 14, 16, 20. 3, 30, 12, 3, 30, 12. So you don't have to worry about counting the totals again. The totals are going to stay the same. But this time I want you to try on your own. Based on the table, what is the experimental probability of someone ordering a chocolate ice cream in a waffle cone with strawberries? Again, go back, look at this one to help you out because there's a lot to it. Try it on your own, pause the video. Good luck to you. If you have questions, let us know. All right, the probability of getting chocolate ice cream was 14 out of 50. Oh, my mouse is going slow. 14 out of 50. Sorry, I think sorry. Jack O'Hare gets stuck in there and that makes it go slow. See, now it's good. Let me try that again. That 14 was kind of ugly. There we go. Now the probability of getting it in a waffle cone was 15 out of 50. The probability of picking strawberries for your topping was 12/45. Again, it doesn't matter if you simplify at the beginning or the end. I like to simplify at the beginning when the numbers are smaller because I don't want to have huge ugly numbers when I'm multiplying. 14 and 50, I can get 2 into both of those. I can divide them both by 2 to get 7/25. 15 divided by 50, I can divide 5 into both of those. And I get 3/10. And then 12 and 45, I can divide 3 into both of those. And I get 4/15. That I would have to multiply all those together. Again, it's going to be a little bit ugly. With these numbers. I apologize. If I do 7 times 3 times 4, I get 84 over 25 times 10 times 15, 3,750. Yikes, that's a little bit ugly. I can divide what number into both of these because they're even. I can both divide them by 2. So that's going to give me 42 over, we're going to take that number and divide it by 2 because Miss Rose is not doing that in her head right now. Divided by 1,875. And there's another number that can go into both of these. 3. 42 divided by 3. It's going to give you 14. 1875 divided by 3 gives me 625. That's kind of ugly. I had to do that twice. But there's this thing called cross simplification. And I see here 3 and 15, their numerator and denominator, those can simplify because they're opposites. 3 divided by 3 would give me 1. 15 divided by 3 would give me 5. And I see I can also simplify this 7 and that 4 because they're both even. 4 divided by 2 gives me 2. 10 divided by 2 gives me 5. And now if I remultiply, on my top I have 7 times 1 times 2. 7 times 1 times 2. That gives me that 14 still. And then for my denominator, I have 25 times 5 times 5, which still gives me that 625. These questions get tricky because of the simplifying. They really do. A good test-taking strategy would be to just put that ugly number, turn it into decimal form, and see what fractions match that ugly decimal that you're going to get from dividing those numbers. The biggest things to remember, ladies and gents, the biggest thing to remember is you need to find the probability of each and multiply them together. Multiply them together. And then make sure that you simplify at the very end. When we're taking our test, we'll give you partial credit if you don't simplify because you've got the right answer, it's just not the best answer. And we're looking for the best answer, the one that's simplified. If you have any questions with this, let us know. Maybe you want more problems practicing simplifying fractions. Maybe you want more problems where you can try out drawing the sample space and draw the tree diagrams or make a list. Let us know. All right. Otherwise, go ahead and get into the practice for us for today.